All right, today we're going to work on solving literal equations. Literal equations are, well, that phrase is actually something that is fairly new. I haven't used that phrase a whole lot before. But basically what we're dealing with is what do you do when you have more than one variable and you're being told to solve for one of them? And my first outline point here is that you've done this before. You might not know that you've done it before, but you have. Let's look at that first equation here. It's short, it's sweet, 2 steps. Solve 4 plus 2y equals 16. Well, you've done this before. All you have to do is take away 4 from both sides. If you do that, you get 2y equals 12. And then you divide both sides by 2, and you find out that y equals 6. You've done that before. On the right, I gave you a problem that's almost exactly the same. The only difference is instead of 4 plus 2y, it's 4x plus 2y. And you are being asked to solve for y. So suddenly, my students freak out because there are 2 variables. There's an x and a y, and you are being asked to solve for y. I want to make the point, like I said, you've done this before. It looks different, but you still do it the exact same way. Instead of subtracting 4, like we did in the first example, you're just going to subtract 4x instead. It's not that exciting. It's the same thing. Just take the x with you. Now, there is one difference here, and we're going to talk about this in a second. Negative 4x and 16 are not like terms, so you pretty much have to leave it as it is. So you're going to have to write this as 2y equals, and then since negative 4x and 16 are not like terms, you have to just leave them. Put the x first. That's a good habit to get into. You'll be glad you did when we get into the graphing in the next unit. All right, now you're still going to divide by 2, just like you did before. The only difference is here you have to divide everything by 2, and now we have 3 pieces instead of 2. But you're going to get y equals negative 2x plus 8, and that's it. Like I said, it's not as different as you might think it is. I know it's a little bit scary because it has 2 variables, but it's solved the same way. The only difference is there were no like terms. That's really it. That's all it is. So it seems intimidating, but it's the same exact process. So try to get used to that as we go, because it's really not anything to freak out about, even though it seems like my students always do. All right, let's keep going here. That word was however, by the way. It just got cut off on my screenshot. All right, let's go through here. Let's keep going. Once again, I'm just trying to emphasize that you've done this before. On the left, what would we do? Well, we would take away 5 from both sides. You would get 3x equals 16. Divide by 3, and x equals, well, 16 over 3. 3 doesn't go into 16 evenly, so we wouldn't really mess with it. The same thing is going to happen on the right. It said solve 3x plus 5y equals 21 for x. Okay, it's the same thing. Instead of subtracting 5, you're going to subtract 5y. That's the only difference. That's going to give you 3x equals negative 5y plus 21. Remember, they're not like terms, so you have to leave it as it is. From here, you divide both sides by 3, and what you'll probably notice is that 3 does not go into 5, but it does go into 21. So when we write our final answer, we're going to get x equals negative 5/3 y, or negative 5 over 3y, plus 7. The 3 did not go into the 5, but it did go into the 21. All right, let's take a look at the real life examples here. These are actual examples that do exist. They do take place in math and in real life. And you will be asked to deal with questions like this sometimes. For instance, solve d equals rt for r. D equals rt is a really common formula. Distance equals rate times time. And students act like they've never heard of that formula before, but that's really not true. I mean, if you drive 60 miles an hour for 2 hours, how far did you go? 60 times 2? Yeah, 120 miles. So people act like they've never seen it before, but they have. You've used it on a road trip or with common sense or whatever. Anyway, solve d equals rt for r. So we're trying to get the letter r by itself. So we ask ourselves, what is keeping the letter r from being by itself? Well, it's being multiplied by t. So how do you undo multiplying by t? Divide by t. As soon as that happens, the t's will cancel out, and you get r equals d over t. Rate equals distance over time. And that's true. In fact, we'll get to that in just a minute here. Let's move on to the right side next. Solve P equals 2L plus 2W for W. That would be the perimeter of a rectangle or a square, but if it's a square, length and width are the same, so whatever. Anyway, we're trying to get W by itself. First things first, that 2L term is in the way. I don't like it. It needs to go away, so we are going to subtract 2L from both sides. Yes, those are L's. I know it looks like 21. Get over it. So that gives you P minus 2L equals 2W. Remember, they are not like terms, so you can't combine them in this problem. Next, we divide both sides by 2. P over 2 is going to have to stay there. However, 2L divided by 2, in that section, the 2's will cancel out, which is going to leave you with a final answer of W equals P over 2, remember that didn't cancel, minus L. And that L is almost cutting off on the side of the screen there, but that is a letter L. All right, so why do we do it? Why do we work on these real-life examples? Well, there's a pretty good reason, because we use real-life examples in, real life. Let's go through these 2 problems that relate to what we just did. Problem number 1, you traveled 240 miles in 5 hours. How fast were you driving? Well, we could figure it out. Think about it. R equals d over t. We just discovered that. Rate equals distance divided by time. So that's pretty convenient. We know that the distance is 240 miles. We know that the time is 5 hours. 240 divided by 5 is 48. So you were traveling 48 miles per hour. And on a road trip, that's actually a pretty good average. I know when you think of like going on the road, you think of driving 75 miles an hour or whatever. But I mean, you're going to stop. You're probably going to get a bite to eat. You're probably, going to use the restroom, whatever. So if you can average 48 miles an hour on a road trip, you're probably doing pretty good. All right, this other real-life problem, the perimeter of a rectangle is 82 inches. The length is 30. What is the width? Well, how convenient. We already solved for the width. W equals P over 2 minus L. So all you really have to do is plug in 82 for perimeter and plug in 30 for length, because that's what they told us to do. 82 divided by 2 is 41. Then you're going to take away 30. Once again, that cut off. I apologize for that. It is 41 minus 30. 41 minus 30. Sorry about that. And that means 41 minus 30 is 11. So the width would be 11 inches. All right. For these next ones, I want you to pause this. Try these 3 on your own, because in about 10 seconds, I am going to reveal the answers. So if you haven't done them yet, I want you to give them a shot on your own, and then I will reveal the answers. So this is your chance to pause right now, because the answers are about to appear. 4, 3, 2, 1. All right, there's the first answer. See how you did. 4, 3, 2, 1. Here's the second answer. They both come out to fractions there. Both terms on the right come out to fractions. That's okay. And 4, 3, 2, 1. There you go. All right, I hope this helped out a little bit here. Good luck on the rest of your work.